My name is Austin Alf, and this is my design video for TME 499 under Dr. Dillon as part of the Saipan team at University of Washington, Tacoma. I figure it's a good idea to start off with the poster I made for the project to give an overview of said project. Our team is focused on finding a solution to the problem of coastal erosion on the island of Saipan. Currently, the said erosion is doing severe damage to the coastline and threatens significant infrastructure damage to the island as well. This damage would significantly impact the lives of those living on the island, as well as negatively impact the tourism-focused economy of Saipan. Me and my co-conspirator focused on gathering experimental data for water flow around a cylinder. This is in order to confirm previous data, gather new data, and most notably to prepare for more complex testing down the road. We tested a variety of flow rates and cylinder sizes using the flow visualization bench in the fluids lab. For visibility, we used a background image comprised of a variety of dots of varying sizes, and we added a diluted mixture of blue food dye to the water. The methods section of this slide goes into a bit more detail on how we set up our testing. We recorded videos of the data using a smartphone, and I have a couple example videos to show of that. Here we have a video showing the 10 liter per minute flow around the cylinder of 1.5 centimeter radius. This is both our smallest radius cylinder and our slowest flow rate. As you can see here, the dye allows for pretty decent visualization of how the water flows around the cylinder. Just let that finish up real quick. And here we have the other end of the spectrum, which is our larger 3 centimeter radius cylinder at 30 liters per minute. As you can kind of see, the water level for this one is notably higher due to the higher flow rate. And to accommodate for the varying water levels in the later testing, we attached this ruler, as you can see on the right side here. Let's show this real quick. You can also see a little bit of lowering of the water level here as well. As you can see, the water is going much faster, and while the dye isn't quite as thick here, you can still get a pretty good idea of how it's flowing. Going back to the poster, here we do have a couple more examples of other data we gathered, notably some of the original data we gathered, being this one here, which clearly shows a much thicker usage of the dye, which ended up being a little excessive, as well as this should be the 3 centimeter cylinder at 20 liters per minute. It's a little harder to see in there, but you can notice if you're looking carefully that the little dip here is shallower than in the faster flow rate. The main benefit of our testing really is preparation for further, more complex testing down the line with more advanced systems, different size cylinders, all that sort of thing. And now it's time for just a quick personal reflection. This is my first time doing research at UW Tacoma, but not actually UW as a whole. I've done research at the University of Washington, Seattle, in the astronomy department. And the research I did there was a lot more individual instead of team-based, so this definitely gives me a different perspective on research, as well as giving me some more hands-on lab training outside of just what I've done in classes previously. It was an interesting change of pace, just being one small part of a larger project. I imagine this is often how it is in the engineering industry as well, so it was pretty good to get that experience. And as a quick side note, I was not at all prepared for this to be treated like an actual class with coursework and all that. Going back to my research up at UW Seattle, we didn't really do much of that over there. It was entirely just focused on the research itself. But this does give a lot more to the learning experience part of the research instead of just the research part of the research. Well, thank you for watching. That's all I have for you today. This is Austin signing off.